Hello everyone, welcome to the live class. So guys, today we are having another very important session, and in today's session we will do the discussion about the important concepts of solid state physics. So we will start the discussion soon. Once please let me know in the comments, like, is everything all right? Audio, video, slides, everything fine? And if yes, I'm just going to check your comments right now, then we will start the discussion. So please let me know once. Is everything all right and everything like clear? Let me just check your comments once and we'll continue the discussion then. That's good. Very good evening everyone, very good evening Sunil, and that's nice, clear. Now let's just start the discussion guys. So basically in today's session, even if someone is here who is just going to start the preparation, okay, they will be able to get a clear idea about this subject. So it's gonna be important session for everyone. And if you are thinking like, okay, can I just like, even if I have not completed or prepared this subject, is it okay? Will it be good? Can I score good marks even in this case? So I would say, to be in the safer side, okay, you should consider all the 9 subjects, and it is easy, okay, but you should know how you need to consider them and what are the topics you need to prepare out of these subjects. So right now in solid state physics, firstly I will explain some points to you, some tricks I will share, okay, along with the discussion, and then at the end I will provide you the information about the most important topics, or you can say the must to prepare topics from solid state physics, okay, so that everything will be clear to all of you. And let me know, are you all ready for the discussion? But in the starting, I will take just some time to let you know about the Unacademy Plus subscription, and then we will continue the discussion about the topics or concepts and the tricks which we are going to consider in today's session. Hello Prince, very good evening everyone, okay, and very good evening Kaku, Bhavneet, all physics concepts, Raghu Chandra Dev, Bhavneet, and like everyone. Done. Now let's just start the discussion, but as I have told you, like in the starting, I will tell you about the Unacademy Plus subscription, and then we will continue the discussion, okay. So guys, as you all know, there are going to be so many Unacademy Plus courses which are going on Unacademy Plus for your upcoming CSIR NET physics exam preparation, clear. But if you want to attend more regular live classes by all the top educators we are having on Unacademy Plus for your upcoming exam preparation, then you can take the Unacademy Plus subscription. And whenever you will take the Unacademy Plus subscription, you can use and apply the referral code, that is Anjali Arora. As it is mentioned here, by using and by applying this referral code, you will get the 10% discount in the total Unacademy Plus subscription amount. Also guys, let me just provide you the information about the new Unacademy Plus courses as well, because sometimes students are going to have this question that, ma'am, is it okay if I'm taking the subscription right now? So yeah, the answer is yes, because still before your exam, okay, in the remaining days there is gonna be very important discussion, okay, in Unacademy Plus courses. So yeah, you can utilize this time even very well. And do you know, if there is gonna be some target in your life, something for which you are targeting right now, and you are getting even, let's say, some very less time, then you should try to utilize it in the best possible way, okay. It can be anything, it can be any step in your preparation you can take, whether going through the notes, whether just doing the revision or anything, but you should try to give your best in that remaining time, okay. I hope it's clear. Now also guys, whenever you are going to use and apply the referral code, write it as it is, no space in between, spelling should be same. That's how you need to write and apply the referral code to get the 10% discount in the total Unacademy Plus subscription amount. Next thing, on Unacademy Learning app, there is going to be a series of special classes, okay. So here is a series which is recently going on, like it's already going on 4 sessions in this series have already been conducted and 2 more are there. There were total 6 sessions, okay, in this course, this series you can say. So this is about top 50 questions for CSIR NET. Before this, we already had the Forget Me Not Trick sessions. You can check them on Unacademy Learning app. You can check them directly on my profile by searching Anjali Arora, or in the description of this video, you will have the link, okay, of the profile, or to check the special classes. You can even check that, or directly in Unacademy Learning app you can search Anjali Arora. You will get to know about the special classes, the plus course classes, the ongoing courses, the upcoming courses which have been launched, okay, or many other new courses will even be there. Also guys, revision courses, as I have told you, many new courses are going to start. So that means like in the starting in November, okay, you will have the new courses too, okay. There can be practice course, there can be their quick revision course, and like that. So there are different courses by all the top educators, and all these courses together will help you a lot to do the best possible preparation in the remaining time before the exam. Also guys, there is another referral code as well, which is AnjaliALive. You can either use this one or you can use this one, anyone at a time. You can just use one referral code. Both will work, but you can use any one at a time. So use either this or that one, okay. Also guys, if I'm going to talk about the batch course, so there is a batch course which is going on, and it is a crash course for physical science which has started on 1st October. So if anybody will take the Unacademy Plus subscription right now, they will be able to get the recordings of the sessions which have already been conducted in this course. Let's say somebody is taking the subscription right now, okay, so they will be able to get the recordings of all those sessions which have been conducted in a particular course, and that's how you will be able to cover up each and everything. Clear? And there is going to be championship mock test guys, which every one of you can attempt, okay, and that's going to be on Sunday, and on Monday we are going to have its analysis session. So this was all about Unacademy Plus subscription and benefits of taking the Unacademy Plus subscription guys. You will get the benefits as you will be able to get the guidance by all the top educators, okay. Recordings of the live sessions will be available to you, so anytime you can access them, you can check them till the time you are having the Unacademy Plus subscription. Also guys, the PDF of important notes along with the sessions you get, so yeah, that's gonna be another important thing. So anytime if you want to just check out the PDFs quickly, you can check them out, clear, to know about like what discussion has been done during the class and all. So you will be able to know about it quickly. And along with that, you will get to know about the strategy and the best way of preparation in remaining time, how you should utilize your time with the guidance of all the top educators we are having on Unacademy Plus, okay. Now let's talk about the important concepts and topics of solid state physics which we are going to consider in this session. So let me know, are you all ready, and can we start the discussion? Then one by one I will explain all the points to you, okay. So let me know if everything is all right and you all are ready for the discussion. Bhavneet, at the end I will tell you the most important topics of solid state physics. ठीक है? तो उसको भी discussion करेंगे. Done? Guys, also try to participate in the discussion so that I will get to know in between that everything is clear to all of you, okay. And still if you will have any doubt anywhere in between, you can even mention your doubt in the comments that ma'am this is not clear or that is not clear, so I will try to explain that point to you. Done? Can we start the discussion? I'm just waiting for your comments, that you will say yes, yeah, we are ready, yeah, we can now start the discussion and all. So I'm just looking at your comments right now, and now we are going to start the discussion. Bhavneet, Regu Chandradev, okay, Megha, and all physics concepts, and only these many students till now have replied, okay, and Kirti, and Ritu and YB. Okay, so guys, these many students said yes, and more comments about the yes and ready are there, so we can start the discussion. Very good Subramanyam, very good Sunil, very good Sudha. Okay, now let's start the discussion guys. And as I've told you, even if you are someone who is just going to start This preparation about solid state physics, don't worry, you can get it easily after knowing about the important points I'm going to tell you today. At the end, I will tell you the most important points or topics in solid state physics which every student needs to cover. Okay, so let's start now. Basically guys, when we start studying or preparing solid state physics, okay, there are going to be few terms and words you can say which should be clear to all of us, and when they will be clear to us, it will become easy for us to understand any question of solid state physics just by reading it, and everything will be clear to us. Okay, so what are these words? I will quickly explain those words to you, or I will let you know about their definition and what they mean, like we mean by them, clear, and wherever you are going to get them, how you can understand those points well. So let's talk about it now. See guys, the first term is lattice. If we are talking about lattice, what is this lattice? See, to explain it, I'm going to tell you that let's say this is a space. Okay, so in this space, if I'm considering that this is a point, just be careful about this thing what I'm going to tell you now. Point, 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 point. I'm trying to just keep the distance equal vertically as well as horizontally between two particular points. Point, 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 like that. Okay, in this case, what is going to happen, if we are having the imaginary points, okay, in space which have been arranged periodically, so we call it a lattice. So can you see these points I have shown you right now? Like I just told you that there is a point like that. Can you see them? No. So this was just the periodic arrangement of imaginary points in space. Sometimes we call them mathematical points as well. It is just a basic definition of lattice. Why we need lattice? Now the second point is, because see, there is a crystal. Solid state physics is basically related, you can relate it with the study of crystals, the phenomena, the properties, and all those things you are going to study about the crystals. So lattice is first thing which should be clear to you, because when you are going to do the research or when you are going to observe some phenomena related to crystal, you need to just have some idea about this thing, that how you will explain it to someone. If you have done some research and you want to tell like, okay, I have observed this phenomena at this particular point or position, how you will tell it to someone that, okay, this is something you have observed. So you need something. Okay, so that's how we are going to consider that lattice and basis together form a crystal, and then further we are going to consider more things within a crystal which will help us to explain the crystal itself and to let someone know that, okay, we are talking about this particular position. So that's how we'll be able to explain it. The second point, which is basis, what is that? That is gonna be a single atom or group of atoms. Okay, a single atom can be there in a basis, we call it monoatomic basis, or if two atoms are together present, okay, and they are going to be together like this, clear, then in that case we call it the diatomic basis. Similarly, if three atoms are together present, we call it triatomic basis. Now, why we need to explain this, like, okay, diatomic or triatomic basis, and what is the role of basis? Basically, let's observe it here. So, here, whenever you will be familiar with the lattice and basis, just by combining them together, you will be able to get a crystal. Now, lattice is like a point here, a point here, a point here. They should be at equal distance, okay, so that they will be visible to you. I am trying to make them little bit larger. Even if a space between 2 points, it's not gonna seem like equal, okay, for all the cases you can consider that same. So in this case, when I'm talking about a basis, in a basis there can be a single atom, let's say only one atom at a time. When you will combine this lattice with this basis, what will happen actually? This atom, and it is the center of the atom. Normally we consider atom in the shape of a sphere, okay? So this is the center of the atom. What will happen? This atom will take its position to all the lattice points. But the question can be, how one single atom can take the position at the lattice point? It is not only about one single atom, it is just a kind of sample that how this crystal is gonna get, like we will have that crystal, okay, or what type of atom will be involved in it or is present. So it was just a sample thing, okay. You will have these atoms in equal numbers as you are having the lattice points. So then those atoms will take their position like this, and let's say the first atom which has been kept here, its center is coinciding with the lattice point. Okay, these points are known as lattice points. So you will have the arrangement throughout the lattice in the exactly same way, that the atom will have its center coinciding with the lattice point. Okay, next point. If we are going to talk about the next point, that's gonna be, this is how we are going to get the crystal. I hope it will be clear. Now we were saying that in a basis there can be two atoms too. So as per the presence of a crystal, a material, okay, what type of crystal it is, it can have the atoms which are having like two atoms combined together, and you can't break them like that. Done. So let's say it is a diatomic basis, out of which one atom is a larger one, another one is a smaller one. Okay, so what will happen, let's say larger one center is present at the lattice point itself. Okay, so now again let's say the smaller atom is present here, so throughout the lattice their presence will be exactly same, and that's how you'll be able to get a crystal. Here we may not be able to observe the 3D case, but exactly same arrangement will be there everywhere. Done. So this is the role of lattice and basis. Now the point is, there are going to be different type of lattices, like the Bravais lattice and the ideal lattice. Ideal means you will have the length of the lattice which is extended till infinity. Okay, that means the lattice is extended, like this one is a lattice here, so it will be extended this side till infinity, dot 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 you can make, this side till infinity, this side till infinity, this side till infinity. So ideal lattice is a lattice which will have no end points, or you can say which will be extended till infinity. Okay, the other lattice is gonna be Bravais lattice. When we are talking about the Bravais lattice, in that case you can consider it as a lattice in which each lattice point will have the same surroundings, okay, or identical surroundings. So if I'm going to say or explain it in this way, that here is a point, okay, or a person is standing at this point, and what we are going to do, we will allow that person to observe his surroundings. When he is just going to observe the surroundings, he will get all these points present in this manner. Okay, that means 1 point here, 1 point here, 1 point here, 1 point here. These are just the points. Okay, so that person has observed the points in the surroundings. What we have done, we have closed his eyes, and we are going to take that person from this point to this point. Now what will happen? Again, when he is going to observe the surroundings, then same type of lattice points are present, and we will allow him to observe the surroundings when he has reached to this point, or we have taken him to this particular point. So any lattice in which each lattice point will have the identical surroundings will be known as the Bravais lattice. Okay, I hope both will be clear, the Bravais lattice as well as the that other one which was our ideal lattice, which will have the infinite length or no endpoints. Okay, what we mean by lattice parameters, see, the distance between two consecutive lattice points is known as lattice parameter. For example, you can see along the x-axis distance between two consecutive lattice points, that is, we have shown it by a. Okay, so that means along x-axis the distance between any two consecutive lattice points will be a, like this. Okay, it will be a, it will even be a, it will be a, it will be a. So about a particular axis, the distance between two consecutive lattice points will be same, and that distance is known as, or that length is known as the lattice parameter, as well as even if you will look at the vertical direction. So these two, they are going to have the distance between two consecutive lattice points is equal to b, and that is another lattice parameter. So these are known as the lattice parameters. Okay, so lattice parameters are also known as lattice constants. Now let's talk about the next question, next point, but before that, please let me know, is everything clear till this point to everyone, or is there any doubt anybody is having? I'm just going to check your comments right now, and then we are going to continue the discussion. That's very good, Prince. We'll talk about that too. Is this clear till this point to everyone, or is there any doubt? If yes, please let me know. Very good, Bhavneet. What about others? Waiting for more reply, and then we are going to talk about the next point. That's good. That's good. It is clear to everyone. Now let's talk about the next point. When we are talking about the next point, that is related to the crystal structure or different crystal systems in 2D. Mainly in 2D case, there are 4 different type of crystal systems. But sometimes some of the students say like, oh, we have observed 5 too. I will let you know why they say 5, because that is all about the Bravais lattice corresponding to those crystal systems. Okay, if I'm talking about the crystal system in 2D, one will be a very easy shape you consider in mathematics when you talk about the 2D shapes. That's gonna be a square, all sides equal, as well as the angle, okay, between any 2 sides will be equal to 90 degrees. Same condition on the lattice parameters we will have corresponding to this type of crystal system. So first crystal system in 2D case will be square. Second one will be the other shape, which is like a modified form of square, which is a rectangle. Okay, only 2 opposite sides will be equal, but the other 2 sides will not be equal. Here you will not call it side, here you will consider it as a lattice constant. Okay, we'll just observe the conditions too. Next point, if I'm going to talk about the next point, that's going to be related to hexagonal case. In hexagonal case, see, the sides will be equal, that means lattice constants about different directions will be equal, but the angle between any 2 will be equal to 120 degrees. So that is the point in the hexagonal case. But when I'm going to talk about the fourth one, which will be oblique. Oblique is basically how you can consider it, that which is not existing or which is not lying in the first 3 cases, which are square, rectangle and hexagonal, which is not existing in any of these three cases, that will be in the oblique category. Have a look at this now and observe the conditions, because you can get the questions based on conditions, based on Bravais lattice, okay, and any one of these points. So yeah, there are chances of getting the questions based on any of these points. Look at this. Crystal system, first one square, second one hexagonal, or you can even write rectangle here, third one rectangle, and then oblique. Clear? Now the point is, what is the Bravais lattice? Bravais lattice you already know, a lattice in which each lattice point is going to have the identical surrounding, that is known as Bravais lattice. Okay, we'll talk about it. See, next point. Square, Bravais lattice will even be square. Hexagonal, Bravais lattice will even be hexagonal. Rectangular, the Bravais lattice we are going to have corresponding to rectangular crystal system. There are 2 different Bravais lattices. One is rectangular primitive, another one is rectangular centered. Okay, what is the difference between the primitive and rectangular centered? I will explain that to you. Now, oblique, corresponding to that, there is oblique Bravais lattice. Okay. Now corresponding to the Bravais lattices, square, square, hexagonal, hexagonal, rectangular, rectangular centered and rectangular primitive both. Okay, so 2 Bravais lattices, oblique, oblique. Okay, next, conditions on the lattice parameters. In this case, A and B both will be equal, while the angle between them will be equal to 90 degrees. Okay, in the hexagonal case, A and B, you already know the lattice parameters. I have shown you on the first slide. Okay, they will be equal, but the angle between them should be 120 degrees. If you are having any such structure or the crystal system given to you which is satisfying this condition, that will be known as the hexagonal one. Okay, for the rectangular case, A and B will not be equal, while the angle between them will be 90 degrees. For the fourth case, here A and B not equal. Okay, A and B not equal, and the angle will even not be equal to 90 degrees. So when you will compare the oblique conditions, okay, you will find it is neither matching with like this one or this one or this one. So it is not gonna match with any of the above conditions, which means it is the one which is going to have all the cases in it which are not present in any of the above cases. So that's how you can say that whatever is remaining, that will be in the oblique case. Okay, next point. Here you are having the rectangular primitive and rectangular centered 2 situations. But what we mean by rectangular primitive or rectangular centered, let's talk about it. If I'm going to talk about the rectangular primitive, what is primitive means? Primitive means when the effective number of atoms will be equal to 1. Okay, in any given structure or system, that's gonna be the effective number of atoms is equal to 1 or effective number of lattice points is equal to 1. If you want to consider the rectangular case, it is a 2D situation. Done. The point is how much part of this atom is within the rectangle. Just 1/4. This one 1/4. This one 1/4. This one 1/4. So 1 atom 1/1/4 part within the lattice. Okay. How many such atoms are there? 4. Instead of atoms, you can even consider the lattice points. So if the question is like you need to find the number of lattice points or the effective number of lattice points or effective number of atoms, your answer will be same. Effective number of lattice points or effective number of atoms, the answer will be same in both the cases. Now the point is, what you will get from here, you will get just 1. In this case, what are the effective number of atoms? Only 1, which means it is a primitive case. While so it is rectangular primitive. Primitive means effective number of atoms will be equal to 1. Okay, that is this condition is getting satisfied in this case. Next point, if I am going to consider one more atom at the center, how many effective number of atoms now you will have? Total 2, because one from the corner ones and one from this center one, which is completely within this lattice. So how many effective number of atoms are there now? They are going to be total 2, and due to which it is rectangular centered as the atom is present at the center or the lattice point is even present at the center. Okay, and why we call it Bravais lattice? Because even if you will have lattice points at the center of this lattice, because there in a crystal there is not only one lattice, there will be so many lattices like this, and they will be present like in that identical manner. Done. So another, you can see that even if somebody is standing at this lattice point or this lattice point or this lattice point, they will have the identical surroundings as there will be more lattices here. Done. So you will be able to get it why they are considering 2 different type of Bravais lattices in the rectangular case. Okay, because it is possible to consider it and you can get it. Is this clear to everyone till this point? No, Nandini, that will be different distance. Physics paradox, please let me know in which formula you are considering it. Okay, and when you are considering the interatomic distance in a diatomic case, or let's say anywhere, okay, so diatomic case, instead of m, if the masses of 2 atoms is different, so you will have mu present there, and mu means the reduced mass, and if the masses are same, then you will have the reduced mass or the mass equal to the mass itself, then you can put it there. So even if there is gonna be 2 different masses atoms, you can consider it reduced mass, and if it is gonna be same masses atoms, you will consider the same mass at that point. Then, is this clear till this point? Let's talk about the next one. Okay, and physics paradox, you can check the formula like which you are considering, if it is mentioned there somewhere, or which formula you are considering. Okay, so check it once again too. Clear? Now let's talk about the next point, guys. After knowing about this point, we are going to consider a question which has been asked in the previous years in CSIR NET physics exam. Here is a question, its answer steps are even here, so please let me know, is it getting clear to everyone, and is there any doubt anybody is having? If yes, you will let me know about it. This question has been asked in the previous years in CSIR NET physics exam. Please check it once and let me know if there is any doubt. Okay, and if you are getting it, you can start mentioning your answer in the comments, or you can mention done in the comments that yeah, this one is clear. And if somebody is not getting, okay, one more point. The Wigner-Sitt cell, you can consider it same as primitive unit cell. Okay, so Wigner-Sitt cell, you can consider it same as primitive unit cell. Now you can proceed. No, Bhavneet, primitive unit cell. Okay. Or you can say in this case, it will be equal to the area of hexagon. So that's correct for this given situation. Very good, Parth. What about others, guys? Whatever answer you are getting, either mention that, or if you have completed it, you have solved it, you can mention done in the comments, and then we will continue the discussion. So let me know as you will get it done. Very good, Prince. Okay, Subramanyam, let's talk about it. See, basically what is going to happen in this case, the question is the two-dimensional lattice of graphene is an arrangement of carbon atoms forming a honeycomb lattice of lattice spacing A. As shown below, the carbon atoms occupy the vertices. That means here will be a carbon atom, here will be a carbon atom, here will be a carbon atom, like that. So at vertices you are going to have the carbon atoms, and yeah, their size will be same. Their size will not vary as the like we have drawn it here. Okay, their size will remain same everywhere. So you can even have it here at all the vertices. Done. So you can draw it at all these positions. Otherwise somebody will say like, will it not be present at this particular position or anywhere else? No, it will be everywhere. Now the point is, once you have got to know about it, now your question is the Wigner-Smith cell has an area of. Wigner-Smith cell means the primitive unit cell. Okay, you can consider it in this way. Now the next point is, in the hexagonal case, this one, just a second. This hexagon itself is gonna be the primitive cell. Okay. Now the point is, when they are asking you to find the Wigner-Smith cell, in this case, what will happen? You just need to consider the area of one hexagon. Okay. And how you can find it? If you know its direct formula, that's good. If you don't know its direct formula, then you can just divide it into 6 equilateral triangles like this. Why 6 equilateral triangles? Let's say this is the distance A, the lattice spacing, this will be A, 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 and this distance will even be A, because this is the distance between two consecutive lattice points. Okay, and this distance will even be A. As per the property of a hexagon, okay, you are going to have this condition or the equilateral triangles you will get. Now what about the area of one equilateral triangle? That is root 3 upon 4a square. And how many such equilateral triangles are there in this hexagon? 6. 6 into root 3 upon 4a square, you will get 3 root 3 upon 2a square. And that's how you can get your final answer for this question. It's quite easy, but you need to know 2 points mainly here. The first point is Wigner-Smith cell is same as the primitive unit cell. Also, the other point is, in the hexagon case, the primitive cell is same as the hexagon itself. Okay, so 2 main points you need to know. If we are going to talk about the next part of this question, it was this one. I want you to just try to solve this question and let me know as you will get it done. Okay, and let me know whether it is clear or not. Bhavneet, primitive means that is having the effective number of atoms equal to 1. As we have considered in the rectangular case, rectangular centered and rectangular primitive. Primitive means the effective number of atoms is equal to 1. Very good, Prince. Very good, Subramanyam. Very good, Sunil. So guys, you can see as per the crystal structures we have considered, that corresponding to hexagonal, it will be hexagonal Bravais lattice which will exist, and the lattice parameters definition, you know, they are A1 and A2 as shown in the given figure. So you will easily be able to answer it, that it will be A1, A2 and hexagon. So that is option C, which is correct. Is this clear to everyone? Is this clear to everyone? Done? If there is any doubt, you can mention it, you can let me know, and if it is clear, let's talk about the next one. Now here is gonna be a trick. Trick is so easy, okay, and will make this complete table very easy for you. And right now you may observe it and you will say like, oh, there are so many conditions in this case, how will be able to memorize them? So I will tell you how you will be able to memorize them. Okay, so let me just introduce that trick and you will get it clearly. So the trick is city. You can write it as capital C and capital T instead of writing its complete spelling. City. Okay. Over real, first alphabet should be capital. Home. Maintain 3 clinic. You can consider it a kind of song, and if you want, if you like, you can sing it. Clear? Just make your own tone, the way you want to sing it, the way you will like to consider it. Okay, you can consider that and sing it, and the repetition of this statement should be there in this song twice or thrice, so that you will get familiar with it and you will have a good command on the statement. Once you are going to get familiar with it, song means you just need to repeat it, and yeah, if you will make it a little more interesting by considering it a kind of song, you will have good command on it too. Okay, so that was the reason of saying this. Now after you will get familiar with this statement, that is city over real home maintain 3 clinic. City over real home maintain 3 clinic. Okay, now what you need to do, after this you need to consider the sequence. C for cubic, T for tetragonal, O for orthorhombic, R for rhombohedral, H for hexagonal, M for monoclinic, 3 clinic means triclinic. Okay, now once again, now you will mention it in the comments. I'm going to ask you, are you ready? Please let me know once in the comments. And can I ask you the sequence once? Because once you will have a clear idea about the sequence, that complete table will become very easy for you. Okay, are you ready? Can I ask you from this sequence? I will take few alphabets and I'm going to ask you what it is representing, and you need to mention for that only. Done? Okay, let me know. R for as per the 3D crystal systems, not anything. Okay? If you know, you can mention it in the comments. If you don't know, then once again we'll just repeat it. Very good, Regu Chandradev. Very good, Prince. Very good, Shubham. Very good, Subramanyam. That's very good, everyone. What about others? What about others? Just few students have mentioned it till now. Clear? If you know it, that's good. It's rhombohedral. Okay. Now what we need to do, once you got to know about all these terms, let's have a look at the sequence and let's have a look at the table. Let's have a look at this thing, that how this sequence will help you to prepare the conditions. See, C for cubic, T for tetragonal, O for orthorhombic, R for rhombohedral, or rhombohedral is also known as trigonal, H for hexagonal, M for monoclinic, T for triclinic. Okay, all these you know. Next, what you need to do. See, I will again show you the condition one separately and then we will talk about it here. Okay, I hope this is clear to every one of you. See, what I am going to do, I am saying observe the pattern, what we are doing. Is it following a pattern and the repetition of last one once again at the end? Have a look at this. Is it just gonna follow some particular pattern? What I have said, firstly, I have mentioned 1 is equal to 2 is equal to 3. Then I said 1 is equal to 2 but not equal to 3. Then I said 1 not equal to 2 and not equal to 3. Then I said again they are equal. Then I said again right hand side, from the right hand side part 1 not equal to sign we have introduced. Then we have increased the number of not equal to signs from here and here. Then again at the last one you are going to have both not equal to. That's what you are having. Clear? If you are going to observe the conditions as per the 3D crystal system, look at this. A equal to B equal to C, A equal to B not equal to C, A not equal to B not equal to C. You have introduced 1 not equal to here. Then you have increased their number, made 2. Then repeat same thing, sequence. Okay, last one is gonna repeat itself because there will not be all the steps completed. Okay, we will not be able to complete them, so we just need to repeat it in this way. So you have memorized the conditions corresponding to lattice parameter with the statement that is city over real home maintain 3 clinic. Okay, that has been done. So all these conditions you have already memorized now. You don't need to give or devote extra time to memorize them. But what about the angle part? Let's talk about them. Basically in 3D case there will be 3 angles which are alpha, beta and gamma. Clear? Now for these 3 angles what is going to happen? Alpha is the angle between C and B. Okay. Beta is the angle between A and C, like ABC 3D case will be there. So gamma will be the angle between A and B, and all 3 are equal. For first 3 cases, when you are starting to make the changes in the ABC, which are the lattice parameters, you will not make any changes in the angles. That means for first 3 cases, when you have just made the changes in ABC, you are not going to make any changes in this part. It is just alpha is equal to beta is equal to gamma is equal to 90 degrees. It will remain same. Now once you have completed the changes in the ABC, okay, you will start making the changes in the alpha, beta, gamma. From the right hand side here we have introduced the not equal to sign. Here also from the right hand side we will start introducing it. That is not equal to 90 degrees. Okay, like that. Alpha is equal to beta is equal to gamma not equal to 90 degrees. Again, once you made gamma not equal to 90 degrees, then you reach to the hexagonal part. Hexagonal condition, you already know that there you will have one angle 120 degrees. So that is gamma. As you had it in the 2D crystal system conditions as well, it will remain same in this case also. That is gamma will be equal to 120 degrees and the other conditions remain same. So due to this hexagonal part, you are going to have this condition. But what about next? You know that you need to make the second one not equal now. Okay, so in angle part it is little bit different, but yeah, still it is gonna work. So now in this case the second one becomes not equal to, but other remains equal to. Okay, now in the last condition everything not equal to, neither they are equal to each other nor they are equal to 90 degrees. So any of these conditions will not get satisfied. Let me know, is this clear now to everyone that how we have considered all these cases and the conditions? If that is clear, that's good. And you can expect a question from this part as well directly. Okay, they can ask you about any of these conditions, or they can ask you about the interplanar spacing. Interplanar spacing is basically the distance between the 2 consecutive parallel planes within a crystal. What we have considered, okay, we have considered that a crystal is made up of planes. Clear? And in those planes, the distance between any 2 consecutive parallel planes is known as interplanar spacing. Sirsa, ECC means end-centered cubic. End-centered cubic. Very good, Prince. Clear? End-centered means what? If let's say this is a room and which is in the shape of a cube. So upper face, okay, the topmost one and the lower face. If at the center of this one and this face there is one atom or the lattice point present only at this pair, okay, it's center, so it is end centered. Or if not at these two faces centers, we can consider them at these two faces centers. So that's why we call it end centered. Okay, that means only at one pair of opposite faces centers you are going to have the atoms present or the lattice points present. Okay, only at one pair. Yes, Sirsa. Interplanar spacing is the distance between the two consecutive parallel planes within a lattice. Interplanar spacing is the distance between two consecutive means if this is one plane, after this plane is present, so consecutive, एक के बाद दूसरा, ठीक है? तो that's how if you are going to measure the distance between two consecutive parallel planes, that is interplanar spacing. Clear? Next point, if we are going to talk about the next condition after knowing about this thing, guys, you can expect a question from the selection rules part. This is basically going to be related to X-ray diffraction topic. Okay, and the questions based on this point have been asked like in the previous years. You can see one question which has been mentioned here along with this question in 2018. Even if you will check, I think, yeah, in 2018 or in some of the recent exams you can even check it. Clear? You will get the questions based on these selection rules. And what are these selection rules? Let's talk about them. And after completing this part, I'm going to tell you about the most important topics from the solid state physics which every one of you need to prepare, and they are very much expected as well in your upcoming exam. Okay. It's a distance between the consecutive parallel planes. ठीक है? कोई भी दो जो लगातार प्रेजेंट होंगे ना पैरेलल प्लेन्स, जैसे ये है इसके बाद ये है, तो इन दोनों के बीच की जो डिस्टेंस होगी उसको क्या बोलेंगे हम? इंटरप्लेनर स्पेसिंग. क्लियर? नाउ let's talk about the next point, guys. So here the question is, consider X-ray diffraction from a crystal with a face-centered cubic FCC lattice, the lattice plane for which there is no diffraction peak. Okay, that means diffraction will not take place. To answer any such question where they have given you the Miller indices, they have given you the like these type of values, and they have mentioned what type of a structure a lattice is going to have, whether FCC, BCC or simple cubic or ECC. Okay, in that case even there are few examples which you should know that what type of structures are gonna be there. For example, NaCl. Anybody knows what is gonna be the type of lattice, okay, which will be in NaCl? In NaCl case, what type of lattice you can have? Like BCC, FCC, simple cubic, ECC, or any of these? That's very good. It is basically which one? I will let you know. I'm just waiting for your comments and I will let you know then. What about others? Just few students have mentioned it. So this is one of the examples that you need to know about the most common. Just a second. The most common and the most expected type of crystals which we are having, corresponding to them what kind of lattice is present, that should be clear to us, because every time they may not give us the name of the lattice. So at that point of time we have to consider it on our own that, oh, this one is gonna be there. Okay, so it should even be clear, guys. All are in the options. Simple cubic is there, BCC is there, FCC is there, like all are there in the options. But actually it's gonna have the FCC, okay, you can say crystal lattice for the NaCl crystal. I will even tell you the question corresponding to that. Okay, do you want to know about that question? Which was, what was that question? Prince, not only zinc, I think you can get zinc sulfide. Okay, and we will try to consider the different type of lattices corresponding to the different type of crystals. Okay, after completing this part we will talk about that question too. I will let you know in which year it has been asked and what was the statement given in the question. Clear? See guys, so in this type of questions what you need to do, once you have got to know about the type of lattice, एक second, Okay, you have got to know about the type of lattice, that is FCC. Now they are asking that there is no diffraction peak. What is the condition for FCC to get the diffraction peak? That is this one. All odd or all even values of HKL. Now what are these HKL? HKL means the Miller indices. HKL means the Miller indices. Okay. So in that case, what is going to happen? See, if all H, K and L will be even, or all H, K and L will be odd, okay, then only you will get, or you will be able to find the diffraction peak in case of FCC lattice. Now the point is, no diffraction peak. No diffraction peak means what? No diffraction peak means that they will not satisfy the condition corresponding to which you can observe the diffraction peak. That means here if we are going to observe option A, 2, 1, 2, it is even, but this one is odd. Here all odd, here all even, here all odd. So the condition which is corresponding to FCC case is getting satisfied in this case, in this case, in this case. Either all even or all odd are there, but in this case it is not getting satisfied, which means in this case there will be no diffraction peak which you will observe or you will be able to get. Okay, next point. The other type of question which you can expect in the exam, that's gonna be related to interplanar spacing. Okay, so there is a formula corresponding to interplanar spacing. I will tell you that question after this part. See, for possible values of HKL, you have observed the concepts corresponding to them. Okay, it's here that for simple cubic, what will be the allowed planes, okay, corresponding to which you can get the diffraction peaks. They are all possible values of HKL in case of simple cubic as per the selection rule, corresponding to which you can get the diffraction peaks or reflection will be possible. One more thing I would like to tell you here, that sometimes if somebody is just going to prepare this topic for the very first time, when they will observe that somewhere we are calling it diffraction, somewhere we are calling it reflection, what is going to happen? So basically guys, in the X-ray diffraction phenomena, when you observe it, okay, for the crystal, so in that case the diffraction and reflection phenomena are going to be same. So anywhere you can use the word diffraction or you can use the word reflection. Don't worry about that. Okay, even if we are calling it reflection, we are talking about diffraction too. When we are talking about diffraction, we are considering reflection, so we can interchange the words anywhere. Okay, now next point. The point is corresponding to BCC case, when you will be able to get the diffraction peak, that will be when even value of H plus K plus L you are getting. That means the sum of HKL, that's gonna be even. Then you will be able to get the diffraction peak in case of BCC lattice. Okay, for FCC we have already considered for this particular question. Now after knowing about the HKL values corresponding to which we will be able to get the diffraction peak, next thing is about interplanar spacing. There is a formula for interplanar spacing, and because there are chances that you can expect the questions based on it in your upcoming exam, so that's how, see, the interplanar spacing for the allowed values of HKL will be this one, that is 1 upon root H upon A square plus K upon B square plus L upon C square. While when there is any HKL value given to you for which you will not be able to get the diffraction peak, okay, then you have to take 1 upon 2 term in the starting, and that is the formula you will have. Clear? So be careful about it. And the one question based on the interplanar spacing, you can see it here. Okay, all the steps have even been mentioned, but you can try it once so that you will be able to know about the procedure or the type of questions you can expect. Now let me just tell you one more question. One more question, okay, which is related to, guys, for HCP there is a different rule, okay, and you have to see that whether it is like the sum of HKL that divisible by 4 or not. Okay, so there are different rules. We'll just try to consider them in some other session. Let me just tell you that question once. And if there is any doubt anybody is having till now, you can even mention it. Guys, the question has been asked in CSIR NET June 2018 exam, and the question is NaCl crystal. Listen to the question statement very carefully. Your doubt about the NaCl crystal like that will get clear. NaCl crystal is a FCC lattice, okay, with a basis consisting of Na positive and Cl negative ions separated by half the body diagonal. Okay, that is a condition for the FCC case. So yeah, that has been mentioned. Of a unit cube, which of the planes corresponding to the Miller indices given below will not give rise to Bragg reflection of X-rays. I am repeating the question once again. NaCl crystal is a FCC lattice with a basis consisting of Na positive and Cl negative ions separated by half the body diagonal of a unit cube, which of the planes corresponding to the Miller indices given below will not give rise to Bragg reflection. Just be careful about the options I am telling you now. Will not give rise to the Bragg reflection of X-rays. First option is 220. Option A is 220. Option B is 242. Option C is 221. Option D is 311. Now you need to tell me that which will not give rise to Bragg reflection in the FCC lattice. If you have got the answer, you can mention it in the comments. And this question has been asked in June 2018. Sirsa, which formula? Option C is correct according to you, and that was 221. That's correct. Okay, because in this case it is a mixture of even and odd values, and that's how it will be correct. Clear? Now let me know till this point the discussion we have done, is that clear to everyone? Now let me just tell you about the important formulae once. Here is the are the steps, and here is the formula. So guys, important topics from solid state physics are, the first one is crystal structure. Crystal structure part is not just having one topic in it. There are so many points in this one which you need to prepare. Points related to direct lattice, points related to reciprocal lattice. Okay, to understand the crystal and to know about all its properties, there are two different type of lattices we are going to have. One is known as direct lattice and another one is known as the reciprocal lattice. Once we start the discussion about both these lattices, then we are going to have the concept of brilliant zones. That should be clear. What is the boundary of first brilliant zone? What will be the boundary of second brilliant zone? Okay. Then after that you will reach to after completing this much part, you are going to have there will be in between, there are few more points in this crystal structure. Even this was the part of crystal structure we have completed till now. Miller indices will be there and all these things. Then you have to consider lattice vibrations. In lattice vibration part, dispersion relation, 1D monoatomic lattice vibration, 1D diatomic lattice vibrations, their dispersion relation, the value of omega in different cases. Okay, when K is small, when K is large, then the optical and acoustical modes or the branches you will get. So what are the values and what are the conditions corresponding to them? They should be clear to you. After that, if we are going to talk about the third most important topic, that will be related to superconductivity part. Superconductors are going to have few more points in them which are very important. After this part, you can consider the semiconductors like the Hall coefficient, Hall effect and all other related expressions from the semiconductor part. So these four are must to prepare topics from the solid state physics. Even if I'm going to talk about rest of the topics like bondings in solids, magnetic behavior or properties, of solids, okay, and Fermi energy, Fermi velocity, Einstein's temperature, Debye temperature, so all these, and density of states. So these are gonna be the very important topics, okay. You can consider the bondings in solids and the magnetic behavior or magnetic properties. Magnetic properties is even more important than that, the bondings in solids, but still, if possible, you should try to consider the first 4 on the priority basis. After completing the first 4 I have told you, then you can start considering Fermi energy, Fermi velocity, Debye temperature, Einstein temperature, and the density of states concept. After that, rest of the topics you can consider, okay. So thank you so much everyone for joining this session. Sirsa, yeah, let me just tell you about that question. So in this question, they have given you the information about the 2 different type of, you can say, the transition is taking place. Look at this. A simple cubic crystal with lattice parameter AC undergoes transition into a tetragonal. It was simple cubic, but now the transition has taken place and it has become tetragonal. Then they have given you the conditions corresponding to AT, BT. That means in the suffix when T has been shown, they are the parameters corresponding to tetragonal case. How they are related to the cubic case, that relation has been provided here, or it has been shown here. After that, it's gonna be the C parameter, okay, the third one corresponding to tetragonal, which is related to 2AC. Clear? That is twice of AC, because in the simple cubic case, all the dimensions will be same, so A, B, C will be equal. That's why only one has been shown as a lattice parameter. Now, what they have asked, the ratio of the interplanar spacing of 101 planes for the cubic and the tetragonal structure is. Miller indices are going to have a property, guys. The property is that the Miller indices of any 2 parallel planes will always be same. So अगर ये plane है और ये plane है और दोनों parallel हैं, तो इसका जो Miller indices होगा वो इसके भी होंगे. तो इस केस में आपको इसलिए एक ही Miller indices दिया गया है, okay, this one, and that's what you need to do. You know the basic formula of interplanar spacing जो हमने पहले mention किया है. But what is going to happen in the tetragonal case? A, B, C all will not be equal to each other. So in that case, as per the condition of tetragonal, you will be able to observe it, or even as per the information given in the question, you can make the changes in the formula of interplanar spacing. After finding it, what you can do, you just need to get the interplanar spacing for simple cubic ones and then tetragonal, take the ratio and get the final answer. Very simple steps, but for this one, you should know about the interplanar spacing formula, which we have considered. It is here. Done. I hope it will be clear now, but still if somebody is having any doubt, please let me know. And if it is clear, that's very good. Okay. And thank you so much everyone for watching this video till the end and for joining this session. Also guys, now we will have our YouTube session next week on Tuesday. Okay, so you can join it. Yes Sirsa. First step में you are just using the interplanar spacing formula. ठीक है, और उसमें आपको टेट्रागोनल के कॉरेस्पॉन्डिंग जो लेटिस पैरामीटर्स दिए हैं ना, उनको कंसीडर करना है कि ABC इक्वल है या अनइक्वल है उसके अकॉर्डिंग. सिरसा, क्योंकि A और B इक्वल थे तो h² और k² का जो डिनोमिनेटर था वो सेम हो गया, लेकिन C जो था वो A और B के इक्वल नहीं है टेट्रागोनल के केस में, तो इसलिए लास्ट वाला जो होगा वो आपका C वाला जो डिनोमिनेटर है दैट विल बी लाइक अ सेपरेट टर्म यू हैव टू राइट. आप वैल्यूज जब देखेंगे जो क्वेश्चन में दी हुई है, तो उन वैल्यूज के कॉरेस्पॉन्डिंग आपको वही सेम एक्सप्रेशन मिल जाएगा फ्रॉम द बेसिक फॉर्मूला ऑफ इंटरप्लेनर स्पेसिंग. ओके, जब तीनों इक्वल होते हैं तो एक कॉमन डिनोमिनेटर बन जाता है आफ्टर टेकिंग एलसीएम, बट तीनों सेम नहीं है तो अभी हमने सेपरेट डिनोमिनेटर रखा है. फिजिक्स पैराडॉक्स you can consider like somewhere around 25 marks, 20-25 marks. Okay, or it's a like at least the topics you can prepare easily, you should prepare them. Okay, I would still say कि just try to cover up at least that portion which you can easily do, and if even there will be 5 questions, you will be familiar with 3 at least if you are preparing all the important topics. Okay, thank you so much everyone for joining this session. Also guys, if you want to attend more regular live classes of well structured and well planned courses which are going on Unacademy Plus for your upcoming exam preparation, then you can take the Unacademy Plus subscription also by using and by applying the referral code, that is Anjali Arora. As it is mentioned here, you can get the 10% discount in the total Unacademy Plus subscription amount. there are going to be many new Unacademy Plus courses which will still start before your exam. So if you want to practice the important questions, if you want to do the quick revision about the topics, and even if you will take the subscription right now, you will get the recordings of the sessions which have been conducted in any course. So that's how you will even be able to cover up that part. You will be able to watch the recordings of those sessions, and it will be very much beneficial for you in this way. Clear? Also guys, I have already provided you the information about the spatial classes in the starting, the revision courses which will start soon. Okay, the batch course which is already going on, and the championship mock test. Okay, so I have already provided you all these points and their information in the starting. Now, okay, if you want to attend more regular live classes on Unacademy Plus, then you can take the Unacademy Plus subscription, and all these things together will help you a lot to do the best possible preparation in the remaining time before the exam. Thank you so much everyone for joining this session. Thank you.